So in this demo, I'm going to reference badge number 4, the Data Lake Workshop. That's on the Snowflake University. It's a free course. It's part of the Hands-on Essentials series. The Data Lake Workshop is quite new and it teaches you how to work with unstructured data as well as geospatial data. So in this demo, I'm going to take you through a couple of lessons in real time from that particular workshop. And I would encourage you to check that out if you're interested in learning more. I'll pop a link to the workshop in the comments of this video below. Now, very helpfully, Snowflake provides a couple of files that contain geospatial data in both JSON and parquet format on Amazon S3, and they allow public access to those files in that bucket. In order to work with the data that sits in these public S3 buckets, we need to create 2 external name stages. And if you don't know what they are, I'll add a pop-up banner at the top of the screen now, so you can go back and check out a previous video that talks you through this. In this instance, for this particular demo, however, there are some JSON files in this folder location within this public S3 bucket. This JSON data contains some coordinates, longitude and latitude coordinates essentially, in a JSON format that specifies a trail along a path or a road. Similarly, we have another folder at trails_parquet, similar data but in a parquet format. So in order to access this data in S3 and work with it, we need to create 2 external name stages. If we execute that command, we're going to create these 2 stages. Effectively, these are pointers to our S3 bucket location. So now we can list the files within these 2 stages by just running the list command and specify an external stage. Note I've had to add the ampersand at the start of the stage name to be able to query it effectively. So if we look at the JSON external stage, we can see we've got 4 different files in there. It gives us the size and when it was last modified, as well as the MD5 checksum. And in the parquet folder, we have 1 parquet file in there as well. So we can check using that list command that we can see the actual files within those folders, and it verifies that we can access the data within there. So next, before we can actually work with the data, we need to tell Snowflake how to interpret these different files. I mentioned that some are in JSON, some are in parquet format. We need to let Snowflake know that's the case. And in order to do that, we need to create something called a file format. So we're going to need 2 of them, one for JSON file types and one for parquet file types. We're going to keep this as simple as possible at the moment. There's a load of different options that you can specify as part of your file format, such as header rows and different delimiters, and if you want to ignore trailing spaces and so on. We're just keeping this very simple for this particular demo and just providing the type of data it is. So now if we want to query the data, we don't actually need to import or copy that data into Snowflake to be able to query it. We can actually query it in place for discovery analytics purposes, for example. We don't need to move that data out of our S3 bucket and into Snowflake. As long as we have an external name stage set up, we can access that data in place and query it as it sits within the S3 folder. So to do that, I can specify a particular column position when I'm querying my JSON data. Notice that I'm referencing my file format I've just created, which tells Snowflake how to interpret and read that data. So that if I execute this particular query, you can see that it's retrieving some of the data from the JSON data in the S3 folder. We can query the parquet file in exactly the same way, but simply we need to change the file format, of course, to tell Snowflake what file format to apply to this external stage. Execute that query, and again we can see that data coming back again. Now we're probably going to want to add a little bit of formatting around that data and make it more readable. So let's start with the parquet file. We can use a syntax like this where we're specifying different tags, if you like, within the data. So you can see I've got sequence_1, so I'm referencing it here. Trail name, for example, again I'm referencing trail name here. This type I'm specifying the data type I want to convert it to. I'm specifying as a varchar. I'm also pulling out latitude, longitude, elevation and sequence underscore 2, again specifying my file format. Let's execute that and see what that data now looks like. So now we get a more recognizable tabular data format. Again, this is not sitting in a relational table within Snowflake. It's still sitting in a native parquet format in the S3 bucket location. So this is almost like a schema on read, where the format has been applied at runtime, at execution time when I run this query, and it gives us a tabular format and sort of flattens out that data for us. So we can see, if we look at the latitude and longitude, we can see we're getting some errors with the data and the number of decimal points that we have to deal with here. We want to tidy that up so we've got some data we can work with. In order to do that, I'm going to amend the query I've just ran slightly. And in order to get a level of really high level degree of accuracy, we probably only need to go to 8 decimal places. So notice I'm going to use the 2 colons again to specify a data type, just like I did with the trail name when I was told Snowflake to treat that as a varchar. This time I specify it as a number with 8 decimal places. I'm also dropping some of the columns I don't need, sequence underscore 2 and elevation in this case, and I'm ordering by the point ID. So I get all of the different points, geocoordinates, latitude and longitude in order. So let's execute that command. Okay, so now we can see we're getting the latitude and longitude back. Less number of decimal places, but now we don't have any issues with interpreting that data. We have the trail name, we've got the point ID in order. Typically what you want to do here is you probably want to encapsulate this logic within a view. That becomes even more important if you want to point a dashboarding tool at it, for example, like Tableau, Power BI, or Looker. Then you can interpret this data really easily by just pointing to the view, and it provides that flattened data set for you. Alternatively, you might want to allow your data scientist or data analyst to query that data, and instead of exposing them to the complexities of how to flatten and cast different data types of a parquet file, you can simply just wrap that logic in a standard view like this. So we've got create, replace view, cherry underscore creek trail, and then I've got my select statement I just ran there. So let's create that view. So now we've got the view to work with. What's interesting, if I go and execute the view, I'm limited to the top 100 records. So don't forget, that's querying the data that sits in the S3 bucket now. Trade-off is performance. It's going to take longer because it's not stored in Snowflake's native columnar compressed format within Snowflake. So although you don't need to load it in, you can query it in place. The price you pay is a performance trade-off. Now you can see we have the data coming back from our view. I'm just going to copy one of these coordinate pairs here. And I'm going to go into a website which is based upon OpenStreetMap, and it's called WKT Playground. Now in here, this allows you to plot coordinates in here. So if I clear this, I'm going to type in point. I'm going to open the brackets. I'm going to open my brackets. I'm going to go, and I'm going to paste in our coordinates, close the brackets. I'm going to click plot shape. So you see it did something on the screen. We've got a red marker on there, but it doesn't look quite right. But if we actually zoom out, we can see now we have a point plotted on our map with the longitude and latitude coordinates. So that's looking quite promising. So if I wanted to plot more of this, I'm not going to want to type in point every time. I want to format that data a little bit. So let's head back to Snowflake. And let's just select the top 100, a different way of selecting the top 100 records. I've limited 100 here. I'm using top 100 here. Now I'm just adding the long and latitude together with the point name and my parentheses. So when I execute the query, this returns in a format I can readily copy and paste. If I click clear here, if I paste it in here, click plot shape, zoom out again. Now I don't need to do any formatting, so we're getting somewhere now. So we've been using the point function so far, but we can see there's a line string function as well, and that actually will take a set of coordinates and draw and plan out that line based upon the coordinates that we give it. So let's generate that in Snowflake using this query here. And I'm putting a line string function similar to what I did for points, so OpenStreetMap can interpret what I'm doing correctly without me having to go in and manually add anything in there. Notice that we're adding this list ag function in Snowflake. It's actually an aggregate function, and it returns the concatenated input values separated by whatever delimiter we give it. In this case, it's a comma. Let's execute that. Notice I've limited it to 10 records by specifying a where clause that relates to the point ID in there, just so we can check that it works properly. So here we go then. We've got our line string, and we're going to copy that. We're going to clear that, we're going to paste it into here, and we're going to click plot shape. Notice now we've got a line going across this bridge. So that's looking pretty good. So let's go back to Snowflake. Let's just comment out that where clause and generate the full line string based upon all the data that we've got. We're just going to copy that out. We're going to clear this. We're going to paste that in there, and we're going to click plot shape. Notice now that we have a trail generated that runs all the way through our Cherry Creek State Park, right the way into Denver itself. So that's how we use geospatial parquet data, leaving it in S3 and being able to generate coordinates. And you can't currently map the data within Snowflake, so at the minute we're generating points or line strings that we can then use with OpenStreetMap to demonstrate how this can work and how you can visualize that geospatial data. So there's one thing that we haven't done yet. We've used the parquet data. We haven't went back and used the JSON data yet, so let's do that. Let's go back to Snowflake and let's go and look at what that JSON query will look like. So here we're using something called dot notation, where we've got the actual column. Then we've got a level 1 element, level 2, level 3, and then we're casting it as a particular data type. In this case, all of ours are strings, but notice that we're bringing the name coordinates and various sort of geometry settings out from this JSON file. If I execute this particular query, again against the data that sits in our S3 folder, I get this data back. Now, if I click in the whole object result set, sometimes I get this value too large. So let's just click on the next one here. Now I've clicked on the fourth record down and it displays the whole object in this dialog box, and I also get a copy icon here that I can use. In the other ones where the object is too large, I can actually view some of the data now, but notice I don't get that copy icon here, and that's because it can't load up the whole data set that I need to be able to copy it. So if I go down again to that fourth record, come across, notice that the copy icon appears again. I'm going to click to copy that now. And I'm going to use a different mapping website just to visualize this and show you what that looks like. So I'm now in geojson.io into the website, and it appears like this when you first load up the page. In here we can remove the sample JSON that's in here, and then we can paste in our JSON. And notice that it maps the path directly for us straight in there, directly from our JSON data again. So if you found that useful, you want to get into more detail, for free you can go and check out the badge number 4, the Data Lake Workshop, as part of the hands-on series, the Snowflake Essentials. And if you want to go more in depth, stay tuned and I'll tell you some more details about our Master in Snowflake program next. But hopefully you find that video useful and it gives you a flavor of how to use geospatial data in Snowflake and query it using named external stages and leave your data in S3 for discovery analytics or ad hoc analytics purposes. In the meantime, keep watching, keep subscribing, new videos coming soon. I also wanted to let you know about our Master in Snowflake program with myself that we run, and it's an exclusive signature program to help you master Snowflake and learn how to design, implement, and scale solutions in the cloud. And I've designed this program specifically for those people who have either scratched the surface using Snowflake or who are stuck working with legacy on-premise technologies and haven't been invested in by their companies and have fallen behind in their career. And what I've done is packaged up my knowledge and experience of working with Snowflake since 2017 in learning how to package up Snowflake's out-of-the-box capabilities in a way where you can apply them in the real world to address common challenges. So this program isn't about theory. Of course, I need to introduce you to the concepts if you're new to Snowflake, and many of my members are, but it's really about introducing the theory and then in practice how you apply those in the real world. I've been through the pain of understanding what works and what doesn't. Now I've got a formula or a set of recipes, if you like, that show you how to do that. So the Mastering Snowflake program includes in-depth, on-demand video course content that I've created that all include practical hands-on demos. I provide access to all the code, templates, and files that I use as part of those demos, so you can download them and use them freely. You may want to use them in your day-to-day work. You may want to take them and customize them and use them as a starting point. All members on the program get exclusive access to a members-only group where everybody can help each other out and share their knowledge and best practice and get expert advice. Finally, I also carry out a group 60-minute coaching call with all the members, totally optional, where you can ask me anything about Snowflake, data analytics, data strategy, data architecture, you name it, interview advice, and I can help you and give my input and help and support and guidance around that. Finally, you'll get lifetime access to all feature updates. Snowflake's changing and evolving. There's new features and releases every week, and you'll continue to benefit from those updates as well. At a high level, there's 10 modules. This is what we cover, everything ranging from the Snowflake architecture to getting data into Snowflake. And then once you've got data, how do you effectively use it, secure it, share it, and work with it to ensure that you get the maximum value from your Snowflake implementation. If you're interested, I've included the application link in the video description below. If this sounds like the thing that you're looking for and you want to supercharge your career, and if you're ready to take the ultimate step, I'd really encourage you to fill out the application form below.